Today we get to learn about all different kinds of properties. So the first one we have is the identity property. A number doesn't change when 0 is added to it. So 0 is the identity for addition. A number doesn't change when it is multiplied by 1. So 1 is the identity for multiplication. Next property is inverse. When I hear the word inverse, I kind of think of the opposite, and that's exactly what inverses are for addition. It is the opposite sign. It's basically what can you add to your original number so that it equals 0. Well, if you start with a positive negative number, you will add the opposite, so the same number with a negative sign. Or if you start with a negative number, you will add a positive number. For multiplication, you keep the sign, so if you have a positive number, you will keep it positive, or if you start with negative, you'll keep it negative. But you take the reciprocal, so that means you flip the fraction over. So whatever was on the bottom comes on top, and whatever was on top goes to the bottom. So it is the original number times 1 over the original number. And when you put those together, they will equal 1. So let's try some examples. For the additive inverse, look what it says. We take the opposite sign. We have -9, so positive 9. For the multiplicative inverse, we keep the sign, so we know our answer will be negative, and we just flip the fraction over. While 9 is a whole number, -9 is a whole number, but if it was a fraction, it would be on top of a 1. So we're going to take that and flip it over so that the 1 is on top and the 9 is on bottom. I'll do example C, and then you can do B on your own. The additive inverse of -4/3, take the opposite sign, so it will be +4/3. And the multiplicative inverse, same sign, so it is starting negative. I'm going to keep it negative, and I'm just going to flip the 4/3 over, and it will be 3/4. Your job is to do B on your own. We have a couple more properties, so just fill in your notes as I fill this out. The closure property means that if you have a real number and you add another real number to it, your answer will be a real number. For multiplication, if you take a real number and you multiply it by a real number, your answer is going to be a real number. Next is commutative. Commutative is like commuting back and forth to work. I think of things switching places. So for addition, let's pick some easy numbers. How about 1 and 2? 1 plus 2 is 3, right? It'd be the same thing if we flip-flopped them and said 2 plus 1, right? It would still equal 3. So commutative is you switch them left to right. For multiplication, let's keep using 2 and 3. 2 times 3 is 6, right? Well, if we flip-flop and put the 3 first and the 2 second, it still equals 6. For the associative property, we need to have at least 3 numbers because, so let's pick 1 plus 2 plus 3, because we need to have 2 of them in a group like this, and then 1 of them the odd man out like that. So once we have that set up, it's going to be the same thing as keeping those same 3 numbers in the same order, because this isn't the commutative property. We're keeping the order the same. But instead of having the 1 and 2 in a group, we'll put the 2 and 3 in a group together with parentheses, and the 1 will be the odd man out. Either way we write it, this would be 3 plus 3, which is 6, and this would be 1 plus 5, which is 6, so those two are equal. For multiplication, it works the same way, except for instead of plus signs, we'll just have times signs. So let's do 1 times 2 times 3. we'll put the 2 and a 3 in parentheses together. That would be the same thing as if we wrote 1 times 2 times 3, and let's say we put the 1 and the 2 together in parentheses. Either way, the answer to this would be 1 times 6, which is 6, or it would be 2 times 3, which is also 6. The last property is the distributive one, and this kind of combines multiplication and addition. So let's pick a number to multiply by. The number out front is the number you multiply by. So let's do something easy like 2. Then next to it in parentheses, we might have 1 plus 3. Writing something like that is the exact same thing as if you were to distribute the 2. 2 times 1, and then add 2 times 3. Because let's check. This would be 2 times 4, 1 plus 3 is 4, which is 8, and this would be 2 plus 2 times 3, which is 6, that would also be 8. So there's the distributive property. I know you've learned it before, maybe you just needed to be refreshed. On to the next examples. We have 3 square root 2 plus 5 with a 4 multiplied on the outside. See that 4 sitting right there? That means it's multiplied. And it says it's equal to 4 times the square root, or 4 times 3 square root 2 plus 4 times 5. So it looks like they just took the 4 and multiplied it by what was inside those parentheses. So that would be the distributive property. Let's look at 2b. I see a lot of numbers here, so I'm just going to try to first pay attention to the order. I see a 3, a plus 6, and then a negative 6. On the other side, I see a 3, a plus 6, a positive 6, and then a negative 6. So I color-coded those so it would be easier to see with the order. It looks like green, blue, black, green, blue, black. The order is the same, so it's making me think associative. In the first part, the 3 and the 6 are together in parentheses, and in the second side of the equation, the 6 and the negative 6. So this is for sure the associative property, and you can abbreviate. And since these are all plus signs, we would say associative property of addition. If those were all multiplication signs, we'd say the associative property of multiplication. So you go ahead and try 2C and 2D. Now we actually have to use mental math, so try not to have your calculator right next to you. But what we're going to do is find a 20% discount on a $15.60 shirt. Well, let's just make that an easier number. Let's just use $15. A 10% discount would be really easy to find because since there's 1 0 on the 10, all we have to do is take the decimal that would be after the $15 and move it one place. That means 10% of the $15 shirt would be $1.50. But we don't want a 10% discount, we want a 20% discount. So we just need to double it because 20% is 2 times 10. So $1.50 and $1.50 adds up to about $3. So instead of being $15, your shirt would be about $12. Go ahead and try 3B. My hint is to find 10% of that bill and then cut that 10% in half to get the additional 5% to make up the 15. This last example, we need to see if these statements are true, sometimes, always, or never. So we're just going to try to guess by plugging in numbers. So let's see. Is C plus D equal to C if D equals 2? Well, this means we're going to take 2 and plug it in for D. Can we take a number for C give me any number. How about 1? If we add 2 to it, will we come out with our original number, 1? No. Well, what if we try a different number like 0? If we take 0 and add 2, will that equal 0? Of course not. I don't think we're ever going to find a number that if we add 2 to it, you come out with the same number. So this is never true. You can try 4b, and I will try 4c with you. If we take a and add the opposite sign, so let's say 4 and -4, will that be the same thing as taking a different number, 5, and adding -5? I think so, because 4 plus -4 is 0, and 5 plus -5 is 0, and so I don't think it would matter which numbers we picked because we take the opposite sign, and they would always come out to 0. So go ahead and try 4b and 4d, and then write a quick summary and at least one question that you have for me about this lesson. Then you can move on to do your in-class work. Good luck.